Hello, my name is Catalano, and I'm going to be presenting to you my summer research project using Nano-Engineering for enhanced manufacturing of advanced carbon fiber. My project goal is to find a more efficient manufacturing method for composite materials, study the impact of nanoporous networks on void content, and determine the feasibility on complex geometry like L-shapes. A little bit of background first. What are composite materials? Those are materials that are made of a matrix and a fiber. In our lab, we use aerospace grade carbon fiber reinforced polymer. And basically that means that the fiber is the carbon fiber and the matrix is the reinforced polymer. And both are aerospace grade. The current manufacturing method is an autoclave, as we see here in this image. And there's a big chamber for high temperature and applied pressure, and it's very costly and very resource intensive. And the alternative we propose is to use MPNs. So a lab oven for high temperature curing and MPNs for capillary pressure. How this works is that the NPN substitutes the need of an autoclave and its applied pressure by using capillary pressure. Basically, as we see in this image, this is an image of carbon nanotubes, and MPNs work similar to carbon nanotubes. Because of their little grooves and their nanoporous channels, they have capillary pressure, which allows gas to escape through those channels outside of the composite into the pump. And air or gas that is trapped in between the layers of the composite is called voids, and that is very detrimental to the structure of the composite material. It weakens the material. My project consists of 3 types of samples. First, the no-MPN. It was a baseline and it was manufactured, cured in the lab oven, and it had no MPN layers. The NPN is our testing, and it was cured in the same lab oven with MPN layers in between all composite plies. And then the industry standard, which is also the another baseline control, and is cured in the autoclave without any MPN layers. To lay it up, we basically cut the plies and assemble the layers according to the standard. We did 16 plies zigzag between 0 and 90 degrees, as you can see here in this image. And then over here, we vacuum bagged all samples according to the instructions and cured it according to the instructions of the manufacturer of the fiber and the resin, and depending if it was in the autoclave or the lab oven. And then finally, we cut, labeled, and grind all samples according to the standard size. All had the same size, same width, and we grind the sides. And it was all following the ASTM standard here for testing, as I'll talk later. And after curing them, I took 1 sample out of each type and scanned it on an X-ray micro CT, which is an equipment that scans for the volume of the whole sample. And basically there were 3 scan points: the flat top, the curve, and the flat bottom. And these are the specifics, as well as the specifics for the microscope images. For the baseline oven cured no MPN, which we were expecting to see voids, and here we got them. As we see here, we can count up to 16 plies in this image. This is the microscope image, this is the scan, and we see the voids over here. All of these gaps of air that are trapped within the layers, and that weakens the material. Over here, we see our testing, which is oven cured with MPN, and we see it very clean without any voids at all. And over here, we see the industry standard of the autoclave, no MPN, and again, no voids, because again, this is the industry standard. Our results are similar to them. Here we have the void quantifications, since there were over 2,000 projections for each scan point. Here we have the results calculated, and as we expected, no voids or no significant amount of voids on the autoclave or the NPN, but yes, a high percentage of voids in the 3 scan points of the no MPN oven cured. And an interesting note is that it was higher on the curved than in the flat sides. So that gives us that MPN is effectively as good as autoclave in void content removal. And the following steps is to test the following step is to test the strength of each sample. And for that, we're going to follow the ASTM standard of 4-point bending test as we see here in this image. We expect the test to be that MPN and autoclave are the same strength and the unknown MPN to be lower. And these are all references I use for my images and information. And thank you very much for attending my presentation.